Hello everyone, this is a first mini presentation for the weekly assignments or the lectures from the subject Principles of Computer Graphics and Image Processing. And as we're talking about images and processing images, first we should have to know what an image actually is and what it is made of. And the first week task is going to be about pixel operations. So what is an image? What is image represented by, or what are the data structures? I think most of you have already zoomed in or watched an image that is so-called low resolution, and you've seen that it is full of some simple squares of different colors. So yeah, that's what the picture is actually made of. Those are the squares, and those are the squares are called picture elements, or in short, pixels. Well, if you didn't know before, it's better to find out later than never. So there we have it, the pixels. And what is the picture actually made of? It's made of little subpixels, and their structure and their visuals depend on the screening device or the printing device. Whether we are talking about the old TV, the CRT, or the computer, or well, something that is now maybe ancient, and you can see it mostly in the museums, or the actual LCD and LED TV pixels that looks pretty much different. All of them are actually only 3 subpixels, 3 channels, light channels, and there's red, green, and blue. There we have it. This is a picture seen in very large zoom on the desktop or the LCD display. You can see different shades of these colors, and that is by changing the intensities of these colors or these individual channels, RG and B, red, green, and blue. But RGB is not the only color model. We can use also CMYK or SMYK. And the difference is that RGBs are defined by lighting, or the light, as it is additive color model, because when we are adding these colors together, we get the white color. When we are combining SMYK colors, we are getting the black color. So we are actually subtracting from the light. And there are also other color models that are often used in computer graphics. So here we are. We can see that if we want to change the color of a pixel, we have to define different intensities for these 3 channels, and that is actually as we are defining the different intensities of a light from the light source. And it's very similar of how it's actually defined on how the light works in the nature. Mostly we have 255 levels of intensity, and we can also have a much lower quality, or just a few or 1 bit, and that is a black and white image, just values 0 and 1, light and no light. Or without 3 channels, we can use only the light intensity, and then we have the grayscale image from 0 to 255. And by how many intensities we can store into 1 pixel, we get to the color depth, and it is defined by how many bits are used for 1 color. And as we are mostly using 8 bits for each channel, then we have 24. It's like 8 bits times 3 channels. That's 24 bits. And adding alpha channel, we have 32 bits, which is commonly defined as a true color image. or we can have even more bits per color, and then we get also deep color images with 48 bits per color. Well, naturally, in the past we've been using much less bits per color, and so we had 15 bits, we had 8 bits, or even 2 bits as we had only black and white images. So, as I said in the beginning, some term the resolution, what it is actually, I think you know, but when someone says that I have a DSLR camera with 36 megapixels, sure, it's about the resolution, it's about how many pixels the camera can take, and at full HD you get about 2 megapixels, and with this and the size of the image and with true colors, raw image without compression, you know how fast your internet have to be to download or upload or stream the image. So now we're getting to, after the presentation, if we can sum it up, we have the images from the pixels. The pixel is actually made from 3 subparts or 3 channels, that is red, green and blue when we are talking about the color model RGB. There are other different color models. Combining these values or intensities of each channel, we get many different colors, and that should be quite enough for the first assignment. And the first weekly assignment, if I read the instructions, is that you should implement an image filter that transforms the color of each pixel in a defined way. To load the image, use the image lena.rgb, which is in raw form. That means it's stored only with RGB values, no compression. And so you have to then store the resulting image in, again, the raw format in the most efficient way possible. As we are in the subject principles of computer graphics and image processing, we are learning the principles, so please don't use any libraries, even if there are some. And so the task specification will be in your Google Classroom assignment, which is already created. If you open your CLion IDE with your repository, you will find on the left side the project. Then you have to find your first task and the source code to your first task, a template. Just go to sources, and down there is task 1 field. Double click to open it, and now we can see the template code. If you ever coded in C or Java, the C++, this is actually the C++. However, worry not, it's not that difficult. Maybe later it will be a little bit more, but if you have known C, you could be in a very good start. So what you have to do in this assignment: first you have defined the size of an image. Lena.raw has a size of 512 times 512, which is defined in this line into a sort of a frame buffer. But you don't have defined pixel, which is your task to do, of what the pixel actually is made of and how to define the correct data type. Then you have to load or read lena.raw into the frame buffer as a file. Then read the frame buffer, the whole data, and then you have to process it. Go through each pixel and do the operation that is defined by your task. Finally, just open the result, new file, generate it, just print that you are generating it, and to generate, or actually write it into it, use another correct way to do it. Well, that should be all. If you worked with C, there are some good functions you can use to load the image. and also very similar ones to write the image. Sure, maybe they are not very safe, but we're trying to use it, and just if you have a image that is 500 times 500 pixels, it's not very much, so you can maybe read it sign by sign, or the actually byte by byte. Well, it will take a few seconds, but you'll eventually get there. But if you want to read a few 100 megabytes TIFF image from your DLSR, DCLR, you would really have to wait maybe even for a few minutes to load it and also to save it. So try to get the image possibly in the most fastest way. Well, yeah. Okay, so that would be all, and good luck with your assignment. If you have any questions, just write it into your classroom